This is the belt work. Got the 5 questions right there. There we go. So yeah, we got the formulas for parallelogram, triangle, trapezoid, which we went over last time, and then just whatever a linear pair looks like. Yours doesn't have to look exactly like mine on those. And same with number 5 with the parallel lines and the transversal. And yeah, for number 2 and 3, if you if you wrote that formula differently, that's fine too. But these represent the same thing. If you're still writing that down, excuse me, the objective, I can find area, circumference, diameter, and radius of circles in different contexts. That's fine. But let's go over some, I don't know, parts of circles, just so we can understand that vocabulary very well. And yes, we do expect you to understand this vocabulary when I use it. So when I say diameter, you'll know exactly what I mean, okay? So, let's not do that with the circle. There we go. All right, let's see if this works. Nope. There we go. All right, so this would be a circle. And yeah, since I used the iPad to do it, it looks pretty. So the first thing I'm going to point out on this circle is what we call the circumference. Now, generally when we looked at like rectangles or triangles like this, because we do have a comparison with these types of shapes and circles, okay? It's just, they called it something different just so that we know that we're dealing with circles. So the circumference is kind of the perimeter of, well, it is the perimeter of the circle. Circumference. I think I spelled that right. So that's the circumference. It goes all the way around the circle, and that would be the perimeter, right? Whereas up here with the triangle or rectangles, perimeter is just around the shape, of course, but we called it perimeter. So circumference you could think of as perimeter, and it'd be fine. But the formula for the circumference of a circle is just a little different. So something else you'll need to be aware of is the center of the circle, which is, well, in the center. And yeah, even though that's not right in the center, I did my best on that. So that orange point would represent the center. And we do need to be aware of where the center is, okay? Now, if you trace a line from the center to any point on the outside, like I'll trace a line from this orange point, the center, out here. And of course, it should be a straight line, but I'm working on it. That is what we call radius. Right there, okay? But it has to go from the center to any point on the outside. So it wouldn't have mattered if I put that purple point here or here or here. Anywhere on the outside, it's considered radius. And all the radii, which is plural for radius, are the same length. That's what makes it a circle. Now, if we took a line and we said, hey, I'm going to take this point here, and let's say that I drew the line through that center right there to the other side of the circle. And yes, we'll pretend like my line is straight. That is what we call diameter. Bam. Now circles, another value you need to be aware of is this little symbol right here. Actually, I did that pretty good. Some of you may think that's kind of ugly, but for me, that's not too bad. That is the Greek letter pi. Bam. P. Pi, which I assume was because they meant perimeter of a circle and that stuff. But I actually don't know why they use pi. Well, pi is an irrational number, which means it's a decimal that goes on forever and ever and ever. And you can spend your whole lifetime memorizing those if you'd like. I'm good up to like 2 decimal places. Actually, maybe 4. 4 now. Okay, I've advanced myself up to 4 decimal places. I don't go that far because I can either Google it or just put it in the calculator, and that's good. Okay. Now, in addition to that, this pi value, it is a value. The value of pi escaped mathematicians for a long time, like the actual value of pi. Like the ancient Egyptians kind of knew what it was, and the Greeks did as well, but they didn't know exactly what it was or really how to find it. But they could have found it if all they would have done is taken the circumference of any circle and divided it by the diameter of the same circle. That is how you find pi. So all circles are related by this value pi because the circumference and diameter is, well, proportional as you make these extraordinarily large. Like if you were to consider the universe a circle, I guess, then this would hold true, or even if you took little tiny particles, still it would hold true, okay? Now, you can find pi on the calculator. It's the fourth button down on the left, right? And for the calculators that we use, and we're going to be using that button. Some of you may prefer to use 3.14, and that would be fine as well. I don't use 3.14 because pushing one button instead of 4 is, well, it's a lot more attractive to me, so that's what I'm going to be doing. Okay? Well then, how can you find circumference? Well, if you wanted to find the circumference, what you're going to do is you're going to take that pi value, the pi button, or 3.14, and all you need to do is, especially if we compare it to the radius, is you just need to multiply that by 2 of the radiuses, the radii. Or, if you wanted to, you could take pi and just multiply it by the diameter. Well, aren't those different things? Yeah, the radius and diameter are. But you can see, if you took the radius right here and just continue this purple line all the way across, then you'd have a diameter, right? So there's 2 ways to look at the relationship of radius and diameter. Diameter is either double the radius, or radius is half the diameter. But that would be the formula for finding the circumference of a circle. And yes, I didn't write circumference. I just used the letter C because circumference is a big word. Now, let's say you wanted to find the area of a circle. All right, area of a circle. Well, you're going to take that same pi value. And you can relate this to the radius, but I'm going to make it direct. Well, you can relate that to the diameter, but I'm going to specifically relate this to the radius. So what you're going to do is you're going to take pi and multiply it by the radius, and then the radius again. And there is reasons for this, by the way. We don't have time to go into it today, but like if you chopped up a circle in such a way that it is possible to make kind of what looks like a parallelogram, and then you can kind of derive this formula. Now, some people prefer to look at it like this, where you just take pi and times the radius to the power of 2. That's fine. But because we haven't really gone into too much detail about exponents like this, I'm going to keep it as radius times radius for the most part. We may be asked to change these formulas like we said in the objective, right? You should be able to find the area and circumference. This is a direct calculation with these formulas. But if suddenly they start asking for diameter and radius, then we have to manipulate these formulas. Or you can substitute the values you know and then just solve it like you would an equation with principles of equality, which we're going to see anyways. So what is the formula for the circumference of a circle? Yeah, we just saw that circumference. There's 2 ways to write it. You can take pi times radius, well, times 2. I put 2 times the radius on that last slide, not that it matters. Or you could write the circumference equals the diameter times pi. Or pi times the diameter. That's just the commutative property multiplication, no worries. Well, then what is the formula for the area of a circle? The area of a circle is pi times the radius times the radius, right? And I'm going to keep it like this, radius times radius. It's because we haven't really gone over our exponents unit. So what if you were only given the circumference? Could you find the radius or diameter? Hopefully. So yeah, I guess we'll do it right here. Let's go ahead and manipulate that formula. Let's say if we're given the radius on this, right? Pi times, I'll make it times 2 times the radius. Right here. Well, if I wanted to solve for the radius, if I was given the circumference, then I would manipulate this equation with principles of equality by dividing both sides by pi times 2. And why would we do that? It makes these phantom ones right here, because when you multiply by 1, that's the identity property. So then that would tell us that the radius is the same as the circumference divided by pi times 2. And again, that would be if we were given the circumference. But what about the area? I know it didn't ask for area, but we're going to look at it anyways. The area is pi times radius. Okay. Now for this one, since we are solving for the radius, it may be easier to see it as radius to the power of 2. Now to solve it, the first step I would do is divide both sides by pi to make that a phantom 1. And then we run into this action right here. We've got radius to the power of 2, which equals the area divided by pi. And I don't think we've really learned how to get rid of powers of 2 like that, but it's very easy. Just use the square root on this. Now, notice I just squared the whole left side of that equation. That's the principle of equality. If you square root one side, you got to square root the entire other side. And that would get rid of that exponent for us, which means that if you wanted to solve for the radius, you would take the square root of the area divided by pi. Boom. Now, again, you can use these formulas directly, but I don't think we're going to do that in the problems if we see this stuff. In any case, the circumference of the center of a circle, the center circle of a soccer field is 31.416 yards. I don't know if that's actually true or not, but we'll say that it is. What is the radius of the circle? All right, well, what's the equation? Again, we're looking for the radius. So if I went back just to the original, because they tell us the area of that, it's a circumference rather. Circumference of that center circle, right, that'd be pi times 2 times the radius. So that would be our formula. Let's just replace the radius with the value that was given at 31.416 yards. 31, oh, that was the circumference, dang it. I'm going to replace the right one. The circumference is 31.416 right here. Okay, right, that's what's given. Is our circumference. So what are we going to do? Yep, to solve for r here, principles of equality. Since it's all multiplication, I want to make the pi and the 2 phantom ones. So I'd say, divide by pi. But I can simultaneously divide by 2 at the same time. So those become phantom ones, and then I'm just left with the radius. So in my calculator, since I have it written as a fraction type division, I'm going to use the fraction button, the N over D button. So I got 31.416 all over pi, and I'm using the pi button. Now if you use 3.14, you should be okay, but your answer will be a little bit off from what I get most of the time. So pi times 2, well, maybe not. This one, 5.00001 and some change. And this one just, I guess it didn't say, but I think on the homework, it wants it rounded to the nearest thousandth, which would be the third place value. Well, rounding that to the thousandths still makes it 5. But be careful. I mean, the answer really is not just 5 if you're doing this by hand. You'd have to label it yours. Boom. Found the radius. Hopefully you see just from this example, and there will be other examples like this, but we're just solving an equation. Really, we're evaluating an equation and then solving for the unknown. Sometimes it's the radius, sometimes it's the circumference. We'll see. Number 17, a farmer has, I don't know why it's 17, whatever. A farmer has 100 feet by 100 foot plot of land he needs to water. He has a sprinkler that waters in a circle. The sprinkler has a reach of 50 foot. If he puts the sprinkler in the center of the plot of the land, what percent of the plot will be watered? So they show us the plot here. They gave us a nice diagram. Thank you. And yeah, we see that since it's a 50-foot sprinkler and it goes in a circle, that it goes right up to the edges. You know, these 4 edges of this looks like it's a square plot of land because it's 100 feet by 100 feet. Now we do need to be aware that it's asking for the percentage of the plot that will be watered, and for the diagram that's shown to us, that's just the yellow portion of it. So here's what we got. Let's go ahead and find the actual area of both the square and then the circle. So if I wanted the area of the square, Well, that'd be 100 length times width, or side times side for a square, which is looks like 10,000 square feet. Yeah, square feet right here. All right, but then we need to find the area of the circle. Okay, because this is the amount of area of the plot that is actually getting watered by the sprinkler. Well, that's pi, because it is a circle, times the radius, 50, times the radius, 50. And yes, I'm still using the pi button in my calculator to make this calculation. So I got pi times 50 times 50, and what I get back from the calculator is this 2,500 pi. Now this is, just in case the assignment asks for this, this would be the actual yeah, this is the, it's saying on the assignment that it's the answer in terms of pi, which really is the real answer here. Now, of course, pi is irrational, so that we wouldn't need actually all of the decimal places. But it is the most accurate because it shows the value of pi. So again, this would be in square feet right here. And yeah, again, you're going to be asked for this type of answer on the assignment. But then it's going to say, well, we want the rounded answer to the nearest hundredth, I guess. So on my calculator, it's showing this 2,500 pi. So just right above the enter button is that double arrow button. That'll change it to a decimal. And for me, it shows 7,853.98. Said the nearest hundredth. So that next place value in the thousandths is a 1, which means the 8 will stay the same. And then we can label this in square feet. Okay? Now again, this is not the actual answer that we wanted, because it said we want to know what percentage of the plot will be watered. So, a percent, you can make a percent proportion. Not that you'd have to on this one, but you could. You could say, we don't know the percent. That's what we're trying to figure out. And the entire plot, the whole plot, the total plot is 10,000 square feet. So that would be the denominator. And part of the plot that's being watered is, well, we know that area. And I don't really care which one you use, 78 point. I'll use the decimal one. Most students feel more comfortable with this. So then you can solve this proportion. 78, 100 times 78.93.98, about 10,000. I got 78.5%. I mean, there was more decimals there. But I'm just going to round this to the nearest, well, tenth of a percent. Not that it told me, but I'm going to do that. So that would be 78.5%. That's the amount of property that is actually being watered. When Ruth's family moved during her sophomore year of high school, they stayed in a motel for 3 weeks. Their dog, Frosty, was tied to the corner of the motel on a 60-foot rope. If the motel was 45 by 35 rectangle, that's convenient. How many square feet could Frosty wander? Write the exact answer and the answer to the nearest hundred. All right, these types of problems tend to throw students off real bad. But if you think about it, then it becomes pretty apparent what you need to do. So, it's not a circular motel, it's rectangular. There we go. And I've kind of, purposely exaggerated this so that it's not proportional. And then what do they say? Well, he's on some kind of rope. Here the dog is. And my dog is just a circle. Some of you guys would be like, well, make it a stick figure dog. I don't even know if that works, but whatever. Okay. In any case, here's what they told us. They say that he's on a 60-foot rope, right? 60 feet. And I know this is not proportional either. Not that I care. And I hope you don't either. If you do, then just try your own and make it look much better than mine. But this motel, it's 45 feet by 35 feet. That's what it said right here, okay? And we want to know how many square feet can Frosty wander. I'm just going to use the decimals on this. I'm not going to worry about finding the exact answers, even though we may see them, okay? So I'm using pi on the calculator. Well, here's what happens, okay? Is old Frosty, I think I need space right there, 60 feet, right? So what happens is, from this, if he were to stretch out this rope right here, then, you know, he could go 60 feet in this direction, we'll see, and then, well, 60 feet in that direction. And let's just assume that I drew this real well, okay? All right, we're still making that assumption. Well, you could say, well, you know, I mean, Frosty could go in a full circle like this, and we're still pretending like I'm drawing real well. But you can go in a full circle like this. The problem is you got the hotel in the way, okay? So in actuality, once he gets to this point right here, then he's kind of just looking at this kind of a circle thing right here. And how much rope is he gonna have? Yeah. And then over here, this one right here he's gonna be able to go through this much right here, okay? Now, the reason I did that red and orange part right there is because I'm really ignoring this green part right here. And what I'm looking at here now is 3 different circles. He can cover the area of all 3 circles, assuming there's no other buildings over here, of course. And then we're going to make that assumption. But you got the green circle, you got this red one, and you say, well, that's not a circle. That's right, because I didn't finish it. There is a circle there. And this is important for you to think about. Well, what portion of the circle is this? It's interesting. And then we got this other orange circle right there, okay? Well, what we need is the area from all 3 of these parts, okay? So I would look at the area of the green circle first, and I'm trying to color coordinate this. And I'd say, well, if it was a full circle, then it would be pi times the radius, and this radius, of course, is the length of the leash right here. It's 60. So I'd have 60 times 60. But I can see, just the way that I've drawn it, is that old Frosty, he can only go 3/4 of a circle. So I'm going to multiply that by 3/4 of a circle, because that's as much area as the green circle will cover. Which, when I put into the calculator, let's see what this gives me. And again, I do want the decimal on this one. I'm just going to round this to the nearest tenth. So pi times 60 times 60 times 3/4. And I got 2,700 pi, but I want the decimal, which shows 400. 8,482.3. And yes, this is square feet, but I'm not going to worry about the label until I figure out all 3 parts. Okay? So next up, I'm going to look at the area of this red. Now that's part of a circle. And again, hopefully we understand that it's 1/4 of a circle right there. See that? So when I want the area of that circle, formula stays the same. Pi times the radius times the radius. But we may wonder, well, what is the radius of that circle? Well, the radius would be this part of the rope right there, okay? Now, of course, 35 of it was used up right here. It should be 60 full feet from where he is originally to the edge of that green circle. So how much would be left for the red right here? Well, 60 minus 35, boom, 25 feet, okay? So it's a 25 radius circle. Now this is the formula for the full circle, but what do we see? This is only 1/4 of that actual red circle. So I'm going to multiply it by 1/4, or you could divide it by 4. It's going to give you the same answer. So pi times 25 times 25 times 1 divided by 4. Oh, this one gave me the decimal. It was generous. So the area of the red is 490 point, again, I'm going to the 10th. So I got 0.87, so I'm going to make that 0.9, and that would be in square feet. Well, then we want the area of this orange part right here. And again, we are looking at about 1/4 of that, well, it is 1/4 of that circle. So to find the area of the orange, it's pi. But again, we need the length of that part right there. Well, this is 45. The green is 60. So the orange would be what's left over there, which appears to be 15 feet. So I got pi times 15 times 15. And again, that's just 1/4 of a circle, so times 1/4. So the area of the orange part, just the part that he can go or cover, is pi times 15 times 15 times 1 divided by 4. I get 176.71, so I'm just going to make that 0.7 right there, okay? Now, don't get caught up in the fact that this, like the other part of the red and the orange here, like it's in the green, but we already covered that with the green area right here, okay? So to figure out the amount of area that old Frosty can cover, we're going to take that 8,482.3, and also the 490.9, and the 176.7. Just going to add these together. And that will tell me the total amount of area that little Frosty here can cover. So 3 and a 10 and a 9, carry the 1 is a 9. What's a 15 and a 4 and a 2, a 10 and 11, 9,149.9, again, square feet. Make sure you label that right there. But that would be the total amount of area. In fact, I'll shade it because it's going to look pretty. That was almost completely within the lines. But we've seen my drawings suck, and I don't feel bad about that. I forgot this little part right there. Something about happy trees or something. So there we go. There's the objective for this part of the lesson. I can find area, circumference, diameter, and radius of circles in different contexts.